So we'll be seeing OCNet, which is Object Context Network. It's done by Microsoft.
This acts like a tripod rotation.
It's now the current state of art in city spaces AD20, which means scene parsing, semantic segmentation. Everyone is no semantic segmentation. So, what they're trying to say is, first, over the past recent years, people have proved that context is very important for segmentation networks.
You can explain. It's not, the text is not visible.
So, what that you everyone agrees with, context is important for segmentation. But it took a lot of time to people to just to know that context is important. At least like 2-3 years, people are trying it. It started off with actual FCN doesn't get a lot of context. Context came along with PSPNet across ASPP. PSP was by Google, ASP.
Context in images means the information provided by the neighboring pixels.
All the pixel global context. Say something road is there, it also needs to know the sky.
Okay.
So the whole information helps in labeling this pixel.
Okay.
So people have tried out this different ways. Initially, they were trying in PSP. PSP is Prompt Pooling. So they will for each pixel they kept on increasing the window size. This is one approach. Like multiple windows will be combined.
By window you mean filter?
Filters. They will pull across a very big, so that even small information also passes. The overall big information also passes. But the problem with this network is it will lose a lot of information. So this is very coarse. Information will be very coarse, not final like this. So still if you're pulling, still you're losing the final details when you're pulling at a very high level. So what they did, this is one approach called PSP.
Course will be in the large feature map or small feature map?
Course will be large. It will not be final. You will not get the minute edges and all. You will get the overall picture, but you will lose the fine details.
Okay.
It's pooling. Like, if you pull at a larger filter size, you will only get very high information, right? Not what one other way of is dilated convolutions. People also call it ultras, spatial connectivity. So what they do is, instead of just varying the filter sizes, they use the same concept in dilated convolutions. Like first dilation will be 1, then they will dilate using a filter size of 4. This you understand, right? What my mean 4 is, for every 4 pixels they will take the pixels like this.
Like there's a gap between.
So then they increase to 16. So this also assets, and people later combine both also. That is one more thing. But that is the idea. So networks gave more performance when you get the more context out of the full scene. So this paper directly tries to address this. What they are trying is their core concept is if in an image, if suppose a pixel is there, all the pixels related to this object are of same category. That is their intuition. What I mean by this is, if a pixel is of a particular label, they want to represent that particular pixel as a full representation of all other pixels of the same class. So a pixel of a particular class will be represented by all the pixels of the same class. So how they are achieving this is through self-attention. Self-attention. So their main, they have not done anything new. Only thing they have done is they have tried to apply this self-attention method, which is popularly used in NLP, to computer vision. So attention, I'm not fully sure. Maybe I'll present in the next topic, but to start with attention in computer vision, squeeze and excitation network. So that is when they were first introduced. OCNet, all networks have SE. So they released a paper on that. You are aware? Okay, squeeze and excitation networks. ResNet SE, MobileNet SE, something. So what they do, they just use attentions to guide the convolutions to get important features. Attention, you are aware, right? Same as NLP. Like whatever the full context might be there, but only certain parts of the sentences which will be very useful to for the end task. So they in this also say you don't have to look at the whole image, just a particular region is very important. So for any end task. So how they are applying in squeeze and excitation is they have a squeeze, they try to squeeze. So whatever convolution is there, they try to extract the maximum features. So they do a one cross one convolution. Then they try to upload batch normalization. Some papers do, some papers don't do. Batch norm, then ReLU, then a sigmoid activation, which then gets concatenated, aggregated with the path. So this is called as squeeze and excitation module. So they try to squeeze and whatever important information they will try to add weightage with the sigmoid classical. So this was the approach at the beginning. If you see recent NIPS, so they also have a paper saying you don't need any convolutions for any image task. So they prove that only with self-attention networks you can achieve state of art without using a single layer of CNNs. So, but that is not related to this. So what this
Which paper?
is
Which paper?
standalone self-attention networks. So attention is very important. Like recent all transformer networks in NLP is because of attention. Okay, but to this, what they have done in this paper is they have applied the self-attention module to the parsing problem. How they have done is, according to them, they have two, they call it that object context module. So this is just a module where it can be fit to any layer. Say if you take a FCM, So you have a feature extractor, you have the image, you have the feature extractor, then you have this OC, they call it OCP module, then you upsample it, then you classify it. So this can be, this they have fit into the existing network. So what this basically does is, it does, they have split it into two functions. One is context estimation, one is context aggregation. So what is context estimation? This whole does just the self-retention thing. They are calling in that way. So what does context estimation means? So for each pixel, say for pixel P, a related pixel I, they calculate the relation between, so f, say query is, so f of x p, f of query xi. So xp and xi are the vectors corresponding to the pixel p and I, and they just do a transpose. Then they try to calculate the softmax and they do a normalization across all the. So what this means is, they just for each pixel they try to calculate the similarity score between the other pixel, which might. So if they are all the particular object contacts, they will have more similarity score. Otherwise, it will be less. So then they try to normalize it. This is just the summation of all, for all pixels. This ZP is just a normalization factor. So it is the summation of all the pixels, all these functions. Coming ahead. This will give you a weightage for each pixel across all pixels. So you will just at the end get a weighted vector, which you will multiply with your normal pixels. They call it values. So then you will get the weighted feature map. So this is the aggregation part. So you get a weighted feature map, then you do upsampling or whatever after that.
What are those XP and X? I mean, what are those like? Those are indexes of the. Is that
No, the pixel feature map. So wait until. Sorry, it's a vector. How they are presenting this in attention. This part I have to learn fully, but whatever I understand, I will tell you. So in an attention block, there will be a key value pair. So it will always learn this key value pairs. So what it does, for a given key, what are all the important features for that key? Then you write a query which will query the keys and gives you the only the important values. So this query is like whatever features important for that. This key value pair will contain all the features, but this query will contain what are all important for that object class. So it's like a lookup table. I'm not sure, but this is how it works. So this they have tried to embed it here. So if you look their code, what they do just they fix this. They just have built a module wherein take say a feature extractor is RESTnet, assuming it gives like 2048 dimensions at the end. So what they do, they have predefined sizes of key, value, and query. So say they are defined as 256, 256. So what they do, they have just built. I'll tell what is this keys, how this key is built up of. So key will have a convolution tree with input as 2048 and 256 as output dimension. Then they do a batch normalization. Then that's it. As a sequential block.
That's a key.
This is a representation of the key. And value is the same. It should be the same size. Value.
Value maybe the output is
Value will be the output of the features.
that block.
So query will also be same. This part I'm not sure because in the code they have mentioned the same size for the query and key. That is my only connection why they have given like that. I've checked the original code also, it's the same. I don't understand this part. Why query and key has to be of same sizes. I'll show the code. I tried to visualize also, but this is what I got from visualization. It's like totally meaningless. So this is the attention block. So, it is better if I explain in the code. So they have that OCNet. So they have that OCNet. This is that OCP module. So they just call it OCNet. We are using the base network. So it just tries to downsample it. Then we have the base module. What this base module does, it just has nothing, only a single attention block it has. So what is attention block? So they have this, come here. So they have this value, f value. It's just a convolution between the input channel and the number of value channels we previously defined. This is defined some 256 again. So that is value. Then query set. Query set is same as key set, a sequential block of con2D normalization and value. So then they do a matrix multiplication. It's a matrix multiplication, not a dot product.
Dot product.
So then they apply softmax to get the probabilities. So again they multiply the probabilities to get the weights of that particular value. So then you get the context. They do the aggregation of the context. They just add. Only part I'm not clear is like I'll maybe if we get to know more about attention in CNM, I'll explain next. So why this query is equal to keys, that I'm not sure. Maybe they're expecting to learn everything about attention. So after that, I also learned one thing which I not know. Maybe it's you guys know it. What is that?
Maybe the key is always the same. Is the key always the same?
No, it's training for that loss. No, it will change every time. I'm not sure. See, only they don't have any auxiliary loss. Only loss is your any loss which is cross entropy or whatever. So with that, it's able to learn the important context. But
But the paper has that in that OCNet, it has that I saw that it has they split the feature map into like 2, 4, 6.
This one.
How?
This
That
is just
that just pulling it.
this is the base OCR. So this is just a combination of again Pyramid plus OCP, ASP plus OCC. It's just they're using this module in between to boost performance. Just they're not done in just an extension of this. This is the core part of this. This part and all is already defined in the pyramid net. So there's just in intermediate layers they have added this OCP module and they were able to achieve state of art. They also have proved that it's not because of this architecture, it is only because of this. So they have done studies with only the OCP head and benchmarked it saying that this improves the baseline from this place. And you guys have heard poly learning rate? I also saw it for the first time.
Is it cyclic?
It's cyclic only. Wait, poly learning rate policy. So what they mean is it's just I don't know one type of learning rate policy, learning rate policy. 1 minus the iteration by number of iterations, total number of iterations, whole power 0.9. Poly learning rate. This is one technique they followed. They also have applied OHEM. This is also the first time I'm seeing a segmentation network using a hard negative argument. Then they just did one augmentation of flipping the images, mirroring the images. That's it. On only one axis. Any questions?
They upsample that feature map 8 times, right?
You can do just as I've seen, you can do 8, 16, 32. I've seen you can do anything.
What I'm thinking is like, but when you're upsampling it by a factor of 8, that means like, is it what I'm trying to get at is like, if we upsample it, let's say instead of let's say by 8, but after that OCP network, if we had like features which we could only upsample by 2, then wouldn't like the pixel-wise accuracy would probably be better, right? I mean, when you're upsampling it by the like factor of 8, you're putting a lot of burden on the upsampling operation for it to like. I get what I'm trying to say.
Like
When you're whatever the dimension of the whatever the output of the OCP is, when you're so you're saying that's the final representation, and then your final feature map will be your upsample.
so this will be this. So
Yeah, and then you will upsample that by. My only question is that, not question, just a comment, is that your upsampling is by 8, so you're putting a lot of burden on the upsampling operation for it to like figure out the finer details. But if you probably only upsample it by only by 2 or 4, maybe it would not.
people approve that, no? So as you upsample it more, it will get coarse.
Course at course, yeah.
That's it. That, but any of this paper is not dealing with that part.
Okay.
You have the idea is like they have just you can call this as a pooling in one type of pooling operation. So which you can fit into any network to boost the performance. That's what they are trying to solve. Like what paper? BusterNet I was doing, they were also doing the same thing. BusterNet, so they were trying to only pull important, highly similar vectors to detect forcing, but that's totally different. This attention I'll try to explain in the next class only in detail for computer vision. That's it.